everyone, welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve Leetcode problem 338 counting bits. Given an integer n, return an array answer of length n plus 1 such that for each I 0 less than or equal to I less than or equal to n, answer of I is the number of ones in the binary representation of I. Okay. So the input, let's take an example. Okay, n is equal to 2. So as you can see, 0 contains 0 no 0 1 bits, 1 contains 1 set bit, 2 contains 1 set bit. Okay, so this is how the output will look like. Okay, what will be the brute force approach? Okay, brute force approach is, let's say we have a function which will take a number as an input and count the number of set bits in the given number and returns the number of set bit. Okay, and you can simply iterate from I equal to 0 till all the way and you can call the function to count the number of set bits. Okay, so can we do anything better than this? Okay, as you can see, let's take n is equal to 2. Okay, for n equal to 2 we have 0 comma 1 comma 2. 0 contains 0 set bits, 1 contains 1 set bit, and 2 contains 2 binary representation 1 2 and it will contain 1 set bit. Okay, so my final answer will basically look something like this. For n equal to 3, 0 1 2 3, for these numbers I have to identify the number of set bits in each of its number. So till 2 we know already it contains 1 and 0. For 3 it will be 1 and 1. Okay, so it has 2 set bits. Okay, can we identify some kind of pattern over here? Okay, if you see, for 1, if you left shift it by 1, okay, so it will be 1 0. Okay, and if you left shift it by 1 and if you add 1 to it, then it will be 3. Again, for 2, if you left shift it, it will be 4, and for 2, if you left shift and add 1, it will be 5. Saying for a given number, the number of set bits in it will be the number of set bits in its the number divided by 2, and if the current number, if it is even, then I don't have to add any. It will not, last digit will not contribute any set bit to it, but if it is odd, then it will contribute 1 to the set bits. Okay, so answer of I is basically answer of I divided by 2 plus I modulo 2, which will be either 0 of 1, 0 in the case of even, and 1 in the case of odd. Okay, so we will just iterate from 1 till all the way till the end, and for a given I, we'll just check for its I divided by 2, the number of set bits for I divided by 2, and then we'll add the I modulo 2. Okay, so let's look at the code. So I just define answer as int n plus 1 size, and then I'm iterating from 1 till all the way till the end, and then answer of I will be answer of I divided by 2 plus I modulo 2. Okay, if you run this problem, as you can see, all the base test cases were passed. Let's also try to submit this. As you can see, all the test cases were passed, and also it is pretty efficient solution. Okay, so before jumping dive into analysis of time complexity and space complexity, I highly recommend you to subscribe to my coding channel so that you won't be missing the content I will be posting on daily basis. So as you can see, we are just relying on the previous computer drills. Okay, we are not using any extra computation apart from that. So we are just iterating from 1 till n, and then we are just accumulating the answers. Okay, so the overall time complexity in this case will be order of n, and space complexity is constant space, because we'll not consider answer as part of the space complexity because we are returning it. So I would say constant space complexity, and the time complexity will be order of n. Yeah, that's all about this problem. Hit the like button and share the videos with your friends, and also comment, share your valuable feedback in the comment section. Thank you.